Hello everyone. Hi. Actually, tonight I'm having some small problems with the net, and when the network resumed, I had some problems with the background music of some neighbors. Because of course everybody has to do their own work, so there was a big motor that was going on, and then with that sound, I couldn't conduct the classes. So now I think they are done. So we can continue now with our exercise. That was exercise 9.3. 9.3, if we remember, I think the last class that we stopped last time in the last class we stopped at hello, good evening, uh, at question number 4. So we'll continue from question number 5. Okay, today we'll continue from question number 5. I don't know how the video quality is, so you can kindly bear with the video quality for tonight. And I hope all of you are studying well. Please do work hard. Please do study well. As I always say, never give up. We should enjoy these struggles. Alright, now let's continue with the exercise question number 5. Which term, I believe all of you have your notebook, textbook, pen, paper, everything ready, kept ready in front of you. And I believe that you're on the table, not on the bed, lying and then watching me perform the circus. Alright, so I believe all of you are on the table and then ready to learn. So, alright then. So, we have already learned in the previous video the basic concepts of geometric progression. We have done up to 4 questions. We have done some examples also. 1 or 2 questions we have also done. So we'll continue with question number 5 again. So basically in this exercise there will not be any more new topics that we will be introducing. If there is, then definitely I will give you the concepts for those topics also. So alright then, question number 5. I believe all of you have those previous formula sheets also with you, so you can just keep it with you, in front of you. Don't hide it from yourself, okay? Keep it with you. Alright, so question number 5, I believe all of you are ready. So which term of the following sequence, 2 root 2, comma 4 is 128? So that's the question that is given to us. Which term of the following sequence, 2 root 2, 4, dot, 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 somewhere there is 128. So we are supposed to find out which term is 128. So we have no idea. So let us assume let the nth term, we have no idea which term is 128. So we will assume let the nth term be 128. So let the nth term be 128. So now here in this given progression, what we have is the first term is 2. Common ratio, it is already a geometric progression, we hope, because it's a let's see, 2 root 2 divided by 2. So that will be root over of 2. We can check that also with the other terms. 4 by 2 root 2. So that will be 2 into 2 by 2 root 2. 2 cancels. Of course, this is also root 2. So basically, we will assume definitely it's a geometric progression. So that's why they is telling to find out the which term of the following sequences. So this should be a geometric progression. So since we have the first term, a equal to 2, or the common ratio is equal to root over of 2, we will proceed. So we have assumed, so I'm rubbing this off now. So we have assumed that the nth term be 128. Alright, so then what will happen is that it means the nth term is 128. So nth term is generally denoted by a into r power n minus 1. That is equal to 128. We are assuming that the nth term. So we have to find out n, which term. A, as we have already found out, 2. R was root 2. All power n minus 1 is equal to 128. 128. So that will be, okay, I'll just solve this. After that, it's about simplification, 128 by 2. And as I've told you before also, simplification of course depends on you. You can do it in your own ways. So root over of 2 n minus 1 is equal to 64. So, okay, root 2. Directly to find out and compare the exponents of root 2 might be slightly not very comfortable for us. So 64 we will just factorize. So 64 2, 32, 2, 16. I'm just showing it to you. 8, 2, 4, 2, 2. 1, 2, 3, 4, 5, 6. So this is 2 power 6. 2 to the 4, 4 to the 8 to the 16, 2 power 6. So this, again, just to compare, what we can do is root 2 power n minus 1. This 2, of course, we can again write as root 2 whole square. Isn't it? 2 can be written as root 2 whole square, whole power 6, which already exists. So then that will be root 2 n minus 1 is equal to root 2, 2 6 are 12. So comparing the exponents, what will we have? This implies n minus 1 will be equal to 12. So n will be equal to 12 plus 1, so that will be 13. So it means that the 13th term in the given sequence is 128. So it's a simple question for us. Okay, all right, I think that is done. Let's go to the next question. So the next question that is given is number B, that is root 3 root 3 dot is, which term of this sequence is 729? So almost similarly, so let's simplify straight away. So here a, the first term is root over of 3. Common ratio 3 divided by root over of 3, so 3 class 12 11th standard, so I guess we can do that. That will be root over of 3. Or I'll just show you 3, at least for this question, root 3 into root 3 divided by root 3, so that will be of course root over of 3. Okay, so as we have assumed, let the nth term be 729. So then that means a into r power n minus 1 is 729. A root 3. Common ratio also root 3 n minus 1, 729, almost the same like last question. Now 729, let's try to find out what will be 729. 3, if you factorize 3 3s are 9, 27, 81, 243, 243, 9, root 3 can be written as root 3 power 1. So from law of indices, we can write this as root 3 power 1 plus n minus 1, and this can be written as 3 power 6. So plus 1 minus 1, so we will have here root 3 whole power n equal to, just like the previous question, 3 can be written as root 3 whole square power 6. So root 3 whole power n is equal to root 3 whole power 12. So that simply implies that the 12th term is 729. Alright, so simple questions for us. Simple? Yes, if you practice. Remember, practice makes a man perfect, so practice is very important. Okay, let's go to the next question. We will try to solve as many as possible today also within our limited time. One by 3, 1 by 9, 1 by 27, dot, 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 is how much? 1 by 19683. Ooh, okay. Chalo, we have to solve. So here A, 1 by 3, common ratio 1 by 9 divided by 1 by 3. So 1 by 9 into 3 by 1, so that will be again 1 by 3. So let the nth term be 1 by 19683. So as we know that 3 power 6 is 729. Let's not forget that because it's what, 3. So that is okay. A into r power n minus 1 would be equal to this one if you can simplify, because A is like 1 by 3. R is also 1 by 3, power n minus 1, and it's most probably this is also associated to power 3 only, 19683. Let's try. So that's 7 times 327, 2 left. Another time, 21, 2 left, 24, 26, 2 left, 3 1 3, 4, 5, 3 2 6. One more times, 3, 18, 1, 16, 1 left, 19, 19683. So exactly as expected. This is 1 by 3 power 6, 7, 8, 9. 1 by 3 power 9. So this is 1 by 3 power 9. So that will be 1 by 3 power 1 plus n minus 1 is equal to 1 by 3 power 9. So that will be 1 by 3, almost the same like last time. 1 by 3, and that's up to you. We can do it in many ways. As long as the base is same, we can compare the exponents, that is n is equal to 9. That means the ninth term in this expansion will give us 1 by 19,683. Okay? Alright? Okay, I'll round this off now. Alright, fine then, let's go to the next question again. So the next question is what? For what values of x? For what values of x? For what values of x, the numbers minus 2 by 7, comma x, comma minus 7 by 2 are in GP, are in geometric progression. So for what value of particular, so this one somehow talks about the concept of geometric mean, if you remember. But anyway, let's forget about the geometric mean, even if we have no idea about the geometric mean, which of course I told you in the previous class. Let's assume that we do not know nothing about the geometric mean. But still then we know what is a geometric progression. So it's given that 3 terms. These 3 terms are in geometric progression. So we can just begin like this. Okay, this was question number 6 for those who are wondering. Question number 6. So if minus 2 by 7, comma x minus 7 by 2 are in geometric progression, then what should happen? Then they should have a common ratio, that is x divided by minus 2 by 7 should also be equal to the same common ratio, that is minus 7 by 2 divided by x. We can do it like that, no need to remember the formulas every time. So x into x is x squared, that will be equal to minus 7 by 2 into minus 2 by 7, 2 minus minus plus, finish. So x squared is equal to 1, so that means x is equal to square root of 1, so that will be plus or minus 1. I believe all of you understand this, why we use plus or minus 1 when you go for square root of 1, because it basically is with this concept, x squared is equal to 1. Here what is x? X is just one variable, we have no idea whether it's length, distance, we don't have any value. This is just an arbitrary number, unknown variable. So it can be negative, it can be positive, it can be 0. So in this kind of concepts, for example, like we are assuming x to be like length. So as we know that length cannot be negative, so that's why that time of course we can just ignore the negative value, we just write 1. But here we have no idea what is this x, it is just some value, some variable. So that time we use this plus or minus. Why? Because as the condition suggests, x square equal to 1. That means plus 1 square is also 1, minus 1 square is also 1. So there are two possibilities. It can be plus or it can be minus 1. So that's why we use this plus or minus 1. It's basically from this concept, x square equal to 1. So x square equal to 1, when you go for solving this, minus 1 square will also give me 1, plus 1 square also will give me 1. Okay, provided we do not exactly know what is the value of x. As I said, if it happens to be like length, yeah, like you're assuming the length of a rectangle to be x, that time we know that it's about length, so length cannot be negative. So that time we can just straight away just go for positive values. Okay, different conditions. Okay, it depends on the conditions. Alright, let's move on to the next question, that is about the sum. Okay. Find the sum to indicated terms of in each of the geometric progressions in exercise number 7 to 10. The first one, 7. These are already geometric progressions. So 0.15, 0.015, comma 0.0015, comma dot dot dot. Up to how many terms do we have to find? We have to find its sum up to 20 terms. 20 terms. This side there might be a flash of the light and all, but still I believe you have your textbook, so I'll try not to write too much on that side. Okay, so equal to, please bear with the quality. Alright, so since this is already a geometric progression, we don't have to prove it, so you can turn back your pages. Quickly turn back your pages, find out the formula where I gave you that last class about sum of n terms of a geometric progression. There are 3 conditions depending on the value of the common ratio. If r is 1, we use n times of a. Yeah, thank you, Sunap. Yeah, it's okay about the quality. Yeah, but I'll try to rectify that also very soon. I'm still raw to this. One day I think somebody told me NOOB. Very true, because I'm still very new to this. I'm still learning only, so I'm still trying to make it better and better. So I'll try to rectify this at the earliest. And when r is less than 1, we have one value formula that we use for sum to find out the sum of n terms, and when r is less. So I hope that you have that with you. So let's go for it. First term 0.15. Common ratio 0.015 divided by 0.15. So let's just simplify it at the simplest of possible ways. So 15 by, I know sometimes it might look, yeah, what man, this guy is also doing all the basic things. But no, sometimes it's good, it's interesting also, not just to do simple things. That of course avoids a lot of careless mistakes that we should not ignore. 1 by 10, or in other words 0.1. Now 0.1 is less than 1. 0.1 is less than 1. So as we know, if r is less than 1, then what formula shall we apply? Sn is equal to a into less than 1. So that comes after. Yeah, thank you for that confidence boost. 1 minus r power n divided by 1 minus r. So if r is less than 1, if I'm not mistaken, we use this. So let's try to do that. So what is the value of a? 0.15. 0.15 bracket 1 minus, I'll use the second bracket because our value is 0.1 whole power n divided by 1 minus 0.1 divided by 1 minus 0.1. Alright, okay, let's simplify this a little bit now. Removing this part. So So that should be 0.15. 1 minus 0.1 whole power n divided by, this will be 0.9, I guess subtraction, that one I believe I don't have to show you. So 15. 1 minus 0.1 whole power n divided by 9. Of course, with that, with the decimal, 2 decimals, 0.9, 1 decimal. Just simplifying things, but if you can do it directly, no problem, absolutely no problem. But of course, we have to go for up to 20 terms. So let's just, I forgot to do that. Okay, just go for here, 20. It will not make much difference. So n, you can replace it with 20 because we are told to find the sum up to 20 terms. So 1 0 1 0 3, okay, 5 3 5 2 3 1 0 3 3 3 3s are 9. So that will give us 1 by 6, 1 minus 0.1 in place of n, as I had suggested, as I had told. Since we are exactly told up to how much terms do we have to find out the sum to, so we were told to find the sum to 20 terms, n will be 20. So you can always replace that with 20. So 1 by 6 into 1 minus 0.1 whole power 20. Now who is going to find out 0.1 of the whole power 20? We don't have all the time in the world during the exams. We have only 3 hours. So this one I believe everybody will understand. If you just leave it there, no need to simplify this, let it be. Alright, let it be as it is. When it's too big and all, no, the power is no problem. Alright, okay, go to the next question, please. Number 8. You can get ready with the next question, number 8. Question number 8. 8, root over of 7. Square root of 21, 3 root over of 7, up to how many terms this one? N terms, up to n terms, Okay, let's find out. A, root over of 7. Common ratio, R, root over of 21 divided by root over of 7. Now this one, of course, we can do some factorization, simplification, because square root of 21 we can write as root 7 into 3. No problem with that. Root 7. I'll just show you. So this one we can write root 7 into root over of 3 divided by root over of 7. Root 7 root 7. So the common ratio is root over of 3. Square root of 3. 3. Alright, so square root of 3. Now what is the value of square root of 3? Approximate value? Square root of 3. 1.732. Approximately 1.732. 1.732. So that's greater than 1. That is greater than 1. So we'll be using the other formula. Alright, so in that case, what will be my formula that I'll use? A r power n minus 1. R minus 1, because as we mentioned, the value of R is root of 3 greater than 1. Okay, so what was the value of A, by the way? Root 7. Okay, round it off. No? Root 7. R, root 3. Whole power n. So I'll just use the second bracket. Minus 1. Divided by R value again, root 3 minus 1. Root over of 3 minus 1. Alright, so as per the textbook answer, I've written it down here. So they have simplified. So alright then, we'll simplify by rationalizing the denominator. Please do not forget the basic procedures. So we will rationalize the denominator, that is root 3 plus 1, root 3 plus 1. So that will be root 7. See, root 3 I can write, okay, let me just show you, since we have 1 or 2 more steps to write. Square root of 3 we can write as 3 power 1 by 2, isn't it? minus 1 into root 3 plus 1 divided by root 3 minus 1, root 3 plus 1, a plus b into a minus b, a square minus b square, right? A square minus b square, and square root of 3, as I said, I think this one everybody knows. Square root of 3 means 3 power 1 by 2. Not only for square root of 3, square root of n. Root over of n is n power 1 by 2. So, a little bit of simplification left. Let's do it quickly. So that will be root over of 7. I'll just bring this side. Root over of 3 plus 1. This will be 3 power 1 by 2 into n. N by 2 minus 1 divided by. Do I have to do this? I guess no. Because square root of 3 is, square is 3. Minus 1 square is 1. So 3 minus 1, 2. 3 minus 1, 2. So root over of 7 by 2, root 3 plus 1, 3 power n minus 2 by minus 1. Find that? Okay. Chalo, let's move on to the next question. Okay, this is a good question. I mean, of course, all questions are good, but we will learn something here. Alright, ready? Chalo. Lagao. 1 minus a square minus a cube dot 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 n terms. Okay, they have given a is not equal to minus 1. Take it. If a is not equal to minus 1, no problem. Alright, so what is the first term here? 1. But generally we denote the first term by a. Generally we denote the first term by a. But when we have the letters a in the sequence, in the progression, generally when we have the letters a in the progression, so it's wise enough for us not to use the first term, not to denote the first term with a. You use some other letters. Who told you anything about letters? You can use any letter that you want. That's just given in the textbook. Okay, a, fine. You can use other letters also. Why? Because this a and my first term a, there are chances to be, there are chances for us to confuse between these two values, because this a values are in the sequence, they represent terms of a particular sequence, whereas for us this a represents the first term. So let's try to keep this separate. That is, here first term I will denote by capital A, that is 1. Capital A, T, R, not R, sorry. Similarly, common ratio also. If R is in the given sequence, don't use R as the common ratio. You use some other, capital R maybe, or some other letters, okay? As long as you understand. And what is my common ratio here? R, that is minus A by 1, that is minus A. Now, the question is, this minus A, is it less than 1 or is it going to be greater than 1? And there's a small confusion here, because see, of course, some of you must be thinking, "Arey, what, Benzer? You have a negative sign, so definitely it's less than 1, because it's going to be negative value." True, but nobody knows exactly what the value of A is, I think, because A can be any value. What if A is negative value? Like if the value of A is like minus 1. In that case, minus A is what? Minus of minus 1. Then it becomes plus 1. Then it becomes equal to 1. If A is minus 2, then it is minus 2 minus plus 2. So that's greater than 1 again. Of course, if A is positive plus 2, then minus A is okay, minus 2. So that is less than 1. So this can be any value. Less than or less than 1, greater than 1, equal to 1. So in this case, what you will do is use any one of the two formulas. Use the only thing that they have given is a cannot be minus 1. Okay, that they have given, because if a is minus 1, then minus a is, that is the common ratio, will be minus of minus 1, that is plus 1. That means you will not use the condition for r equal to 1, which is n times of a. That means you can use any one of the two formulas, that is when r is greater than 1 and r is less than 1, except this one, because they have clearly told you if a is cannot be equal to 1, minus 1. Because if a is minus 1, then the common ratio is minus a, so minus minus plus 1. So when r is equal to 1, the Sn formula is n times of a. That they don't want you to be doing. Fine, no problem. But these two, any one that you use, it's your wish. It's up to you. So we'll just use the first one. Okay. We will just use anyone. So I'll just use Sn equal to a 1 minus r power n divided by 1 minus r. You can use the other one also. No problem with that. So a is 1. 1 minus r value is minus a whole power n divided by 1 minus a. So that will give me 1 minus a power n divided by 1 plus a. Okay, so in the textbook they have used this one. The other one also cannot be termed incorrect if you do it the other way around. Okay? Alright, okay, these are certain questions where you can have both sides of the solutions. The next question, please. 10. X power 3, x power 5, x power 7, up to n terms. Here given again, x should not be equal to plus or minus 1. Okay, there may be some reasons. Let's see what may be the possible reason why they don't want you to be using x equal to plus 1 or minus 1. We do not know. Let's see. What is the first term? Here x, so no jamila about the first term. What letter you use? A, first term, x cube. Common ratio r, x power 5 minus x power 3. So that is x power 5 minus 3, law of indices, so x power 2. X square. So no matter what happens, square of any number is always positive. So that's sure. But here also they say you cannot use plus 1 or minus 1, because if x is 1, plus or minus 1, then common ratio is plus or minus 1 whole square, so that is 1. So again here they don't want you to be using that particular formula, n times of a. They don't want to make things, your life so simple. So that's why they're saying no way, don't do it so simple. You try the other formulas, other two formulas. That's what they're trying to say. Okay, chalo, we have no problems because we have practiced well. So but one thing is sure, that x square is always positive, so we'll be here using the formula for greater than 1, because it's always going to be positive. Because even if it's negative now, minus 2 square is 4, so it's always going to be positive. So that Sn formula we will use is a into greater than 1. R power n minus 1 divided by r minus 1. So value of a is x cube r power n, that is x square whole power n minus 1 divided by x square minus 1. x square less than 1, greater than 1, sorry. So, but of course these are variables, x cube, so okay, that will be x cube, x power 2n minus 1 divided by x square minus 1. if x is equal to plus or minus 1. So, but in this kind of cases, we can use the other formula also. Okay, not a big deal. X square, okay, cannot be, x square is always positive no matter what the value of x is. But okay, here also, sorry, you can use this also, but x square, it can be like, yeah, greater than 1, less than 1. It can be less than 1 also again, sorry. It can be greater than 1, that's for sure. It can be less than 1 also, because x if it is like 0.1, then 0.1 square is 0.01. So even if it's positive, it is less than 1. So that, okay, that is also a possibility. So don't worry, this is also correct. Because there are two possibilities here also again. It can be when if x is 2, 2 square, 4, that is greater than 1. So it can be positive. Of course, one thing is sure, it will be positive. By any means, it will be positive, but okay. It can be less than 1, it can be greater than 1. So both are the possibilities here. So either you can have this solution or you can have the other solution also. So you can have both the solutions. Any one will be correct. No problems with that. So it's similar to that previous question only. Okay, it's similar to that previous question. Alright. So square of any number is always positive, but here we were talking about whether r is greater than or less than 1. Both can happen, because if r is 0.1, it's always going to be positive, but it can be less than 1. If r is 2, yeah, it can be again, it will be again positive, but that time it can be greater than 1. So both are the possibilities. So this is 1, but if you want to stick to the textbook answer, no problem. That will be again, you can use any, trust me, you can use any one of the formulas. 1 minus r, both are correct, because no, we are not given the value of x here, so both can be correct. So you can even use this one also, 1 by x power x square whole power n. So that will be 1 minus x, 1 minus x, 1 minus x square. So in that case, your answer will be matching with the textbook. That's all, x power 2n, 1 minus x square. So in this case, of course, your answer will exactly match with the textbook. So if you want the textbook answer, no problem. But the first one that I did, that is also absolutely correct. Absolutely correct. You don't have to worry about that. As I say, now, x, nobody knows exactly what is the value of x. It's just that one thing that we know is it's x squared. Common ratio is x squared. So it can be positive. That it will be positive. Only that is confirmed. But even though it's positive, yes, I contradict. Even though it's positive, I contradict myself. So even though it's positive, there are chances where it will be less than 1. There are also possibilities when it will be greater than 1, because common ratio, nobody knows what is x, so it can be 2 also. Common ratio r equal to 2 square 4, that is again greater than 1. So both chances are there. So you will use any one, okay, whatever you feel like. Question number 11. Evaluate summation of k equal to 1 going from 1 to 11, 2 plus 3 power k. Summation concept. No, it cannot come in negative value, because see, square of any number can never be negative. Square of any number can never be negative. No matter what the value of x is, how can the square of any number be negative? You try, it's not possible. But the thing for our SN formula, our SN formula was not with respect to negative or positive. It was with respect to the value of r. 3 conditions were there: equal to 1, less than 1, greater than 1. So here we just have to see whether it's greater than 1 or less than 1 or equal to 1. So one thing is sure, that it's positive, true, because square of any number is always positive. It cannot be negative, right? Absolutely not. Until unless, of course, it's an imaginary number the way that we've learned in complex numbers. But here we're talking of real numbers, not imaginary numbers. So there are two possibilities, less than 1 or greater than 1. Okay, if r is 0.1, then if x is 0.1, I mean 0.1 square is 0.001, so that's still less than 1. X can be 2 also, so that time 2 square is 4, that is greater than 1, so that's fine. And this one they have told you not to use because r is not equal to plus or minus 1. So these two possibilities, use any one. Just like that previous question, we do not know what is the value of a. So you can use any one of the questions, any one of the formula that you choose. Okay, both will be correct. Don't worry about that. Okay, let's move on to the next question. That is this. Summation concept, I believe all of you understand. Summation means total, adding up one by one. This, all of you already know it, but I'll show you. This simply means summation of this function, 2 plus 3 power k, from k equal to 1 to 11. That is 11 times. Not 11 times, from 1 to 11. That is like first 2 plus 3 power k, 3 power 1, k equal to 1, plus the next, that is 2 plus 3 square, plus 2 plus 3 cube, plus 2 plus 3 power 4, plus together goes on to up to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you'll be adding, it's like, this is the expanded form, this is the short form, no? Compressed form. So this simply means this. So this 2, of course, we can add, no problem. So that will be 2 plus 2 plus 2 plus 11 times. So we are adding 2, how many times? 11 times. Plus this one, 3 power 1 plus 3 square plus 3 cube plus 3 power 11. Plus 3 power 11. So this one, 11 times if you add, that's same as 2 into 11. Plus, okay, this one, I'll just write, okay, let it be as this 3 square. This is a series now. This becomes a series. We have sequences now. When all the terms of a given sequence are added in this form, then that sequence becomes a series. Remember what was the name of this chapter? Sequence and series. Sequence and series. So series are nothing special, not another definition, not a new term and all. No, series means when the terms of a particular sequence, when the terms of the sequences are added together, we get a series. That's the simple meaning of a series. So this will be 22 plus this one. Okay, I'll just write it once again. 3 square, 3 cube, 3 power 11. Let's solve this. The DERMS, terms of the sequence, are, what are they? 3 power 1, 3 square, 3 cube, 311, because this was the sum of the series. So when the terms, physics numerical questions also, I will try, but since I'm busy with this, hardly I'm getting time, but since I'm engrossed with this mathematics, I'll try to find out some time and then solve the numericals, physics numericals for you. I'll try my best. I cannot promise you, but I will try. So the terms of the given sequences are this. As I say, sequences, when the terms of the sequences are added, we get a series. Okay? When the terms of the sequences are added, we get a series. So we are going to take out this sequence. So this is a geometric progression. So here, let's find out the sum. There are two options. You find out the sum. Expand 3 power 1, 3 power 3 square, 3 cube, up to 11 times and then add them up. That's one way. Another way is use the formula. Take advantage of the formula that is given to you. So here A is 3. Common ratio, of course, 3 square by 3. So that is, of course, 3. So this time, yes, we are very clear, 3 is greater than 1, so no problem with this, no guessing part here. So Sn will be, okay, I'll just write Sn first, that is A into 1 r power n minus 1 divided by r minus 1. So what do we have here? S11, isn't it? Because we have to add them up to 11 terms, this term, 11 times. So that will be A, r value, 3 power 11. What was the value of A? 3. 3 power 11 minus 1 divided by 3 minus 1. Divided by 3 minus 1. Maybe you can go back and mark this particular equation as 1. Okay? Or you can even write, so, summation of 2 plus 3 power k, where k going from 1 to 11, can be now written as 22 plus, this one I'll just write directly, that is 3 divided by 2, because 3 minus 1 is 2, into 3 power 11 minus 1. That's the solution for it. Okay? Fine, I'm rubbing it off. My dear students, always do remember, okay, being a student and being a teacher is also no different, because we teachers are also students. Every day we are also learning new things. So we teachers, of course, are the first students. We are also students. So when we study or when we practice, mistakes, problems, confusions, it will always be a part of our life. That time only don't give up. Okay, that time only don't give up. Careless mistakes, confusions, that is bound to happen for the rest. Nobody is perfect. Nobody knows everything. Nobody knows everything. Okay, so problems, confusions, it will be there. That time don't give up. That time work consistently. Mistakes will happen. It's okay if you make mistakes, no problem. You work properly, sincerely. Do it again. Next time you will not be making any mistakes. Presence of mind is important. Yes. So don't worry if you make mistakes and all. Okay, these are just part and parcel of being a student. Being a student in part and parcel of life, of course, in general. Anyway, number 12. The sum of the first 3 terms. Remember again, yesterday I gave you a note again. Generally, if the sum of the first 3 terms and the product especially is given, that time I told you what to do. So if the sum of the first 3 terms of a GP is 39 by 10, now it's the time to use that. And the product is 1. So this time product is given, sum of the 3 terms is also given. Yes, absolutely, hard work is the key to success. Very true, hard work is always the key to success. And remember, we are also working very hard. We want you also to work very hard so that you can lead a successful life in the future. And not only in studies, of course, hard work we need in our day-to-day life, everywhere. Okay, not only in education or in studies. Only people who work hard have a happy life. It's not that you have all the money in the world, so you're always happy. Absolutely not. Happiness is different. The sum of the first 3 terms of a GP is 39 by 10 and the product is 1. Find the common ratio and the terms. So if you remember, I had told you when 3 terms are given in GP and the product is also given, what do? Let the 3 terms be A by R, A, AR. That's what I told you to assume. Right? I hope I'm correct there. You can let me know. I think these were the 3 terms which I told you to use, especially when 3 terms of a GP are given, wasn't it? A by R, A and AR. I gave you for 4 terms also. Right? Okay, so let the 3 terms be these 3 terms. So what is given to us is their sum. That is, I'll just write here, A by R plus A plus AR. The sum of the 3 terms is given to be 39 by 10. So maybe we can take a common, 1 by r plus 1 plus r equal to 39 by 10. Of course, we're not getting anything from here, but let's see what we can have possibly. 39 by 10. And the product, that is a by r into ar, that is r cancel, and the product is how much? 1. That means a, that is a cube is equal to 1. So immediately here we get the value of a, that is 1. Because since it's a cube, so it's not square, so a cube, only plus 1 cube will give me 1, because minus 1 cube here this time will give me minus 1. So careful with these powers also. If it's square plus or minus 1, but cube, no, only positive value, cube will give me positive values, isn't it? So this time here, of course, it's plus 1. So, okay, so we already have the value of a here. We already have the value of a here, so find that. So going back to equation 1. So our job was to find out what? Find the common ratio and the terms. So first term is already found. So from 1, a is already 1. I'm already using it, already 1. So 1 by r plus 1 plus r is equal to 39 by 10. Let's solve this and find out the value of the common ratio. So by taking LCM quickly, 1 plus r square is equal to 39 by 10. So that's going to be r square 10 times r square plus r plus 1, 39r. Now time to do some simplification. 10r square plus 10r minus 39r equal to 0. So that's 10r square minus 29r plus 1 is equal to 0. Alright, so the sum of the first three terms is this, and the product is 1. So a, we have already got 1. So we have, sorry, this is 10. 10 ones are 10 what? Then we also, 10 ones are 10. So now 10 tens are 100. How do we simplify this? 100, 10 tens are 100, 29, okay, 25 fours are 100. So we can make use of that. 25 fours are 100. So that will be 10r square minus 25r minus 4r plus 10 is equal to 0. So let us just simplify this. 5r, so 5 2s are 10, minus 5 minus 2. 2r minus 5 is equal to 0. So 2r minus 5, 5r minus 2 is equal to 0. So then this implies either 2r minus 5 is equal to 0, that is r equal to 5 by 2, or 5r minus 2 is equal to 0, or r is equal to 2 by 5. Both can be possibilities. Remember, because we're here, we're just talking of r, common ratio. So common ratio can be anything, negative, positive, any value. So we have two possibilities of r, that is either 5 by 2 or 2 by 5. Okay, so that's the first part of the question being done. So once the common ratio is found, they tell us to find out the terms also. Not a big problem there. When r is equal to 5 by 2, the terms are, what were the terms? A by r, a r. So let's simplify this. 5 by 2. A value was 1. R value is 5 by 2. A value was 1. A value was 1 into 5 by 2. So when r is equal to 5 by 2, the terms are 2 by 5, 1, 5 by 2. So when the common ratio value is 5 by 2. The values, the three terms in GP are 2 by 5, comma 1, comma 5 by 2, comma 5 by 2. Done. We'll go to the next one. The next values again. 2 by 5, 1, 5 by 2. That's the first part. Again, we have another value of r, that is, again, when r is equal to 2 by 5. When r is equal to 2 by 5, the terms are same, but common ratio will be different. 2 by 5, 2 by 5, 2 by 5. So that will be 5 by 2. 2 by 5. This is when r is equal to 2 by 5. So that's how it will be done. Okay, so we've already done so many questions. I think we will just wind up here for today, because we should not run out of gas. So we'll leave the rest for the next session. So I think we'll have to do 2 more sessions on this exercise, because this exercise is quite big enough. There are many questions, so we will do it in 2 more parts. The next part we'll try to solve some more questions, and 1 more part where we'll solve, because there are some big questions also. So fine, then we'll wind up here for today. If there were any mistakes, errors on my part, please do forgive me. Careless mistakes I made. If I have made any careless mistakes, please treat me as a human being only. Okay. Alright then, so thank you each and every one of you for being a part of this class. Work hard, study well. My prayers are always with you. And if you have any problems, you know how to get to me, how to reach out to me. I'm always there to help you all. So, alright then, good night from my side for those who are watching now. So, good night each and every one of you. Chuba Jongla, of course, nicknames are Derman. I guess that is Hilol, Snap. Sangeeta, Sanap, yes. So, all of you, a very, 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 very good night. Sleep well, rest well. Okay, see you in the next session then. Till then, take care.